This session is on pollution control, progress in China and the United States, and we have three speakers. The first speaker is Tao Shu, a professor from the College of Urban and Environmental Sciences at Peking University, and we'll start right now. Thank you.
Well, thank you. Good afternoon here, and it's my pleasure to be here to talk about the pollution. Of course, I'm not in a position to let you know the whole picture of China. Just to give you a case study. I'm talking about the PAHs. That's the air pollution, how to emit it, and how to infect the people's health. And yeah, of course, that's related to energy. You're talking about the coal and other things too. And we'll start from return the. It doesn't page down. Okay. So we'll start the introduction, let you know why we do PAHs. It's something forgotten here in the States. It's an old story, but in China, it's still a problem. And we'll now go to the emission and outflows, etc. The pH mainly is from we call the incomplete combustion, all kinds of combustion, from vehicle emission, from the factory, from the coke production. Also, very important in China is from the indoor burning of the solid fuel, as the firewood and the straw. That's something very, very different from the States here. So we look at the 16, we so-called US EPA priority pollutants, PAHs, the parent PAHs. Well, it's not that on the top of the priority list in the States right now. The people here are talking about emerging contaminants. But in China, that's very, very different. We found the pH everywhere, very high concentration in China. So we start from Tianjin. That's a very small scale case study. We look at the Tianjin, and we do a little bit of modeling, and we found out there's a very relatively small area here. The concentration, annual mean concentration, exceeded national standard. Well, national standard is 10 nanogram per cubic meter. I'm talking about the benzopyrene equivalent concentration. Well, unfortunately, there are 41% of people stay in the town, in the middle of the town. So in other words, the 40% of people stay in the environment. The annual mean concentration exceeds national standard, 10 nanogram per cubic meter. At the same time, WHO guideline is 1. So it's 10 times higher than the WHO guideline, but still lots of people stay there. Well, the pH not only stay in China after emission, well, they go everywhere. There's another case study by the U.S. group here in the island in Japan. They monitor the pH concentration in the air. At the same time, they trace back where they came from. So they found out where they get a high concentration, the red one, the black one, is always from China, from the northern China or northeast China, where the low concentration is from the Pacific or Japan island. Well, last year we did another study, look at the pHs and alert. There's a North Pole station. They measure the pH over the year. And we took out the 1 year data, look at the week average pH concentration. And we developed a special model and fit quite well. Then we found out it's actually the pH we found out an alert actually came from the whole area, or the North Hemisphere, in the Russia, in the Europe, and in the United States, North and East China. So certainly it's a long-range transport pollutants. Well, for the next talk, I'm going to talk about is the emission inventory in China. That's we developed, and look at the outflow of these PAHs from China and how they transported among the different provinces. Finally, is human exposure. And I try to go a little bit fast here. And we're talking model today, but certainly in our laboratories, not only the model, we do everything. The monitoring, we do the controlled experiment, and also we do the model. Of course, that's the model I'm going to talk about. And emission inventory is kind of the top-down the practice we did. We look at the 16 PAHs, we collected the emission factor data, and also we use the fuel consumption data in the bottom here. Now, the problem in China is the consumption data is not good enough. Looks different here. Well, anyway, it's kind of a busy slides here. the basic idea is we use the provincial data from the fuel consumption that's available, of course, but for the county data, it's very limited in China. We only found 135 county data here available. So we try to develop a model, predict the energy consumption based on the socio-economic parameter and also the physical condition of the certain province, and then predict the county data and use the county data available for the model validation. This kind of model we developed, and also there's kind of validation. It looks fine. So we come up with the emission inventory. And in 2003, there's total 116 tons the pH emitted in China, and mainly from indoor straw burning and small-scale coke oven and firewood burning. That's a major thing. It's not industry. Well, about 10% of those are the carcinogenic thing. It's compared to the United States, it's around 2.7%. It's much higher, the percentage of the carcinogenic compounds. It's mainly in the east part of China. So we compare with the remote sensing data, the aerosol, it's a very similar pattern. And over the years, start from 1950 to now, it's increasing until 1990, when the coal law is in force. And the small-scale coke oven actually start to phasing out. So now it's actually emissions lower than the 2003. So I skipped the summary. And pH, of course, will leave China. That's one example. It's northeast China. If we look at the whole year's trajectory, we have 3 categories. Sometimes it just stay in the local area, very high polluted case. When I got the very strong the wind from north, it will go down to the whole southern China. Occasionally, some special conditions, this thing will uplift to the very high air. That's start we call the Trans-Pacific long-range transport. And so we developed a model we call the PRIF. I skipped the detail here. And we calculated the model. We look at the outflow of China's pH from China, the 2 compounds. The first day, 5 days, 10 days, you can recognize that after 10 days, the fast is actually cross the North, the American, reach the Atlantic already. So I'll skip that one. Well, around 3 to 10% of the pH emitted in China actually leave China, the coastline, to the Pacific Bay, the other countries in the United States. And of course, still 90% stay in China. So what's happened to these pHs? So we use another model. It's kind of an air transport model. We coupled with the multimedia model, look at the water module and the soil module because they are surface-to-air exchange. So we use this kind of the model to calculate the concentration in the whole China. And model was validated by the soil concentration and also the air concentration. The validation data is not measured by ourselves. It's actually from literature. So we collect the literature from old China and compare these two. There's kind of a scaling factor. I skipped that one too. There's too many of these. And we also compare with the time series, 2 locations. One is Guangzhou, one is Gaosun, and they fit quite well. So the model can tell us the concentration. That's the soil concentration, surface soil concentration in the whole China, and also the concentration in the air, we call the ambient air in 1.5 meter heights. There's a human breath there. And then based on this concentration, we can calculate the health effect. So again, come back to the benzopyrene equivalent concentration, and the national standard is 10. That by average, all Chinese population exposed to a concentration of 7.6 annual mean concentration. Well, it's mostly in the east of China, North Plain and the Sichuan Basin, these kind of places, and convert this to lung cancer risk. We use the dose-response relationship from a study in Xuanwei, China. There's lots of people studied there, and no time for that one. And then we can calculate the lung cancer risk. We use we call the population attributable fraction, got the PAF. We get a number, the 1.6, of course, with the uncertainty range from 0.9 to 2.6. Well, that means that every 100 people develop the lung cancer in China, there are 1.6 people because of the exposure to pHs. well, it's only 1.6%. Well, compared with the smoking, that's over 50% caused by smoking. It looks like it's not a big number, but China has a big population there. So they convert this 1.6 to, you multiply by the total cases of lung cancer each year, and everyone live average 70 years. Then we come up with this, every 100,000 people, there's 50 of them will develop lung cancer because exposure to ambient concentration pHs. Well, if you use this 50 multiplied by the total population in China and divided by 1,000, that's a huge number. We're talking about a very large number of population caused the lung cancer because of the pH exposure, the ambient environment. Well, that's a story from emission to the lung cancer risk. But now we are go further. We like to do the global thing. So we we're working on two things. One is the global combustion fuel inventory. We developed the 64 subtype fuel inventory, and globally, 0.1 by 0.1 degree resolution. At the same time, we developed another set of the emission factor database for the black carbon, CO, CO2, pH, etc. And put two things together, we can get a global emission inventory for different kind of the pollutants, also the greenhouse gas. And start from here, then we can do the exposure the risk assessment, also the climate forcing for the black carbon here. For the pHs, we can do that one. And a college of mine are working on the mercury emission factors. Then can put two things together. Also, we can get a mercury inventory too. And now we'll skip this. That's just a very basic slide. So you can see a list of the 64 type of the combustion fuel we are developing now. And actually, 2007 data is available. So we use the 2007 data. We can have we call the inventory, the global inventory, and the per capita consumption. There's a per capita consumption of biofuel. And the CO2 emission inventory is ready. We are working on that one. The paper are going to submit it maybe next month. This kind of CO2 emission inventory is high resolution. We compare with the literature published data because we have a different type of approach, so we get some different results there too. And well, why it's come back again here, huh? I don't know why where's my last page? Well, it's a wrong circle. The last one is just thank you for everyone. And I lost the last one. I don't know what's the reason. Well, thank you for attention.
Well, thank you. Actually, so I didn't have my notes with me when I introduced Professor Tao, but I want to make sure not only is he a professor in the College of Urban and Environmental Sciences, he's also the dean, and he became a member of the Chinese Academy of Sciences in 2009. So I'm sorry for the short introduction in the very beginning. I think what I'd like to do in this is actually have some questions after each of the talks, rather than do it as a panel, because these talks are going to be quite different. So if you have any questions at this point, we'll entertain those. Please.
Thanks for Professor Tao. My question is, have you ever made case studies for incinerations of municipal solid waste?
Well,
related with lung?
Could you repeat the question, please?
Yeah. Okay, talking about the solid waste and the combustion. Well, for the pH emission in China, so far it's not an important source, because the incineration is not a big deal in China till now. And in the future, certainly we like to include in this in our inventory, actually the 64 types, including the solid waste. We have the fossil fuel, we have the biomass, we also have the solid waste. We try to add this to the inventory.
Well, I just wondered if there was a connection to the food chain. Now, are you starting to look at the relationship with the air and deposition in the food chain?
Yeah, actually, this is it's not a whole story. The exposure through the respiration is only count for somewhere between 10 to 20% of total exposure, as another 80% is from food. And that's all we know. We have 2 case studies in the 2 cities. We know how much people get the pHs from food. But the difficulty for the national, the whole country, the calculation is difficult because the food is not produced locally. So they move around. So we do need some other data to support this kind of study. So far, it's very, very difficult.
Any other questions? Okay, thank you again.
Okay, thank you.